Second order differential equation. To solve a general second order differential equation of the form d2y by dx squared is equal to f of x, we integrate twice and the general solution involves two arbitrary constants. To determine a specific solution curve for the differential equation, we need a point and the first derivative at that particular point. Let's have a look at example 13. Example 13. It says find the general solution of the differential equation d2y by dx squared is equal to x cubed minus 6x plus 12. All right, so let's start by writing d2y by dx squared is equal to x cubed minus 6x plus 12. And what I'm going to do is, let us say I'm going to integrate both sides with respect to x. All right, so if I integrate d2y by dx squared with respect to x, I'm going to get dy by dx, and this is equal to x to the fourth power divided by 4 minus 6x squared divided by 2 plus 12x plus a, which is the constant of integration. All right, so dy by dx would be equal to 1/4 x to the fourth power minus 3x squared plus 12x plus a. All right, now to get the curve means that we have to integrate at least one more time. So let's integrate with respect to x. All right, so this is just equivalent of integration with respect to y. So y is equal to 1/4 x to the fifth power divided by 5 minus 3x to the third power divided by 3 plus 12x squared divided by 2 plus ax plus b, which is the second constant of integration. So we're going to get y is equal to 1/20 x to the fifth power minus x cubed plus 6x squared plus ax plus b. All right, so this would be the general solution or the general equation of the curve. All right, so let's have a look at a second example. Example 14. Example 14 says find the solution of the differential equation d2y by dt squared is equal to 4 sine square t when t is 0, y is 1, and dy by dt is equal to 2. So we got some information there which will allow us to find the two arbitrary constants. So let's start out with d2y by dt squared dt, the integral, is equal to 4 times the integral of sine square t dt. We must remember that cosine 2t is equal to 1 minus 2 sine square t. So sine square t would be equal to 1 minus cos 2t over 2. So over here, if I integrate d2y by dt squared with respect to t, I'm going to get dy by dt. And this is equal to 4 times the integral of sine square t dt, which is 1 minus cosine 2t over 2 dt. So this becomes If I pull out that 2, I have 4 over 2. The integral of 1 minus cosine 2t dt. So we're going to get 2, and if we integrate, we're going to get t minus sine 2t divided by the differential of the inside function, which is 2, plus a, which is the arbitrary constant. So let's expand this. Now we can go back to our, we can then go to our border conditions when t is 0, dy by dt is equal to 2, so we can use that. dy by dt is equal to 2 when t is equal to 0. So we could try and use this to find a. So we have 2 is equal to 2 into 0 minus the sine of 2 times 0 over 2 plus a. So the sine of 0 is 0. So this entire section is going to be 0. And so a is going to be equal to 2. So a is equal to 2. And we can write dy by dt would be equal to, I'm going to expand 2t minus sine 2t plus a, which is 2. All right, so let's integrate one more time. We have what? dy, the integral of dy is equal to 2t minus sine 2t plus 2. And I'm integrating this with respect to t. So we're going to end up with y is equal to 2t squared divided by 2 minus, if I integrate sine, I'm going to get minus cos. So this is minus the cosine of 2t divided by the differential of the inside function, which is 2 plus 2t plus b, which is our second arbitrary constant. So now we have y is equal to t squared plus the cosine of 2t over 2 plus 2t plus b. All right? And we can go back up to check our border condition. All right? Y is equal to 1 when t is 0, so we can use that. Y is equal to 1 when t is 0. So y is 1 when t is 0. Y is equal to 1 when t is equal to 0. So we have 1 is equal to 0 squared plus the cosine of 2 times 0 over 2 plus 2 times 0 plus b. All right, so this would become 1 is equal to a half plus b. And the reason for that is because the cosine, 2 times 0 is 0, and the cosine of 0 is 1. All right, so therefore b is equal to 1 minus a half, which is equal to a half. All right, and so our particular solution would be y is equal to t squared plus a half cos 2t plus 2t plus b, which is equal to a half.